Earth and the universe, exploring the universe. Now what is a galaxy? Now we have universe, right? The universe consists of galaxy. Galaxies in further they consist of solar systems, stars, right? Now we have to look into these terms. We are exploring the universe. Now what is a galaxy? It is a cluster of the stars. We have 1,00,000,000 stars present in a galaxy. Galaxy might be circular. The shape of the galaxy might be circular, spiral, or it is shapeless, right? We have two galaxies known to each other. Milky Way galaxy is also known as Akash Ganga, and then we know Andromeda galaxy, which is the closest big galaxy naked eyes, which can be viewed through the naked eyes. So we have Andromeda galaxy is the closest big galaxy which is visible through the naked eyes. Closest big galaxy which is visible to the naked eyes is what we call it as a Andromeda galaxy, right? Now we have the galaxy. Once again, we will just go for it. Galaxy, it is a cluster of the stars. It can be spiral or circular. Spiral galaxy is what we call it as a Milky Way galaxy, or it is also known as Akash Ganga, the nearest galaxy to the Earth. Or the Sun, the Milky Way is Canis Major dwarf, Sagittarius dwarf, which are elliptical. Andromeda galaxy is a big galaxy which is visible through naked eyes, right? Now what is insolation? Insolation is the incoming solar radiation. The incoming light from the sun is what we call it as the Earth. The incoming light from the sun is what we call it as the insolation. Sun rays, the reason for sun rays are because of the nuclear fusion. So we have fusion, right? The nuclear fusion. This is because of nuclear fusion we have the sun's rays. Light from the nearest stars traveling at a speed of light 3 into 10 to the power of 8 meter per second is the speed of light. It reaches 4 years from the nearest star. It takes 4 years if it is traveling at the speed of light. From the nearest star, it takes 4 years. So if the star is having any reaction, we see that reaction after 4 years, right? The time taken for light to come from the sun. The time taken for light to come from the sun is 8 minutes 20 seconds is the time taken for light to reach from the sun is 8:20. 8 plus 2 is 10, right? So 8 minutes 20 seconds. So the distance is 150 million kilometer. You can remember it as 150 million kilometer, or otherwise it is like 14, right? 150.14 million kilometers. So 150.14 million kilometers. This is the distance from the sun to the earth. The moon is located as moon is 3. How do we remember this 3? We usually discuss more about the sun, about the earth and about the moon, right? Same is lunar eclipse. So 3. 8 is 4 plus 4 is 8. 0 kilometer. So this is how somehow we have to remember this. Now the sun is 8 minutes 20 seconds is what we have the sun, right? Now for the moon we will be having the 1 second, sorry. The distance is 3 lakh, and then we have 8, 4, 4 and 20 kilometers. 3 lakh, 3. Sun, earth, moon is 3, right? 8400 kilometer. For the sun, we will be having 8 minutes 20 seconds and then 150.14 million kilometer. Now here we have 384,400 kilometer. Now what is a nebula? Nebula is nothing but an interstellar cloud of dust. We have a cloud and this is what we call it as a nebula. So it is going to have the dust particles. And then the gases, if you are speaking about, hydrogen, helium are the primary gases which is present in the galaxies, right? So hydrogen, helium is included. Now the other gases are iodized. So we are ionic form of the gases which are found inside the galaxies. We have a nebula. It is nothing but a gas. So nebula is nothing but a gas. It consists of the dust, right? It consists of the dust, and after the dust we can say that it consists of hydrogen, helium, ionized gases. After the ionized gases, this is what it consists of. It needs to condense to form stars and galaxies, right? This is what we call it as the nebula. The nearest star to the earth. Now we are seeing the nearest star to the earth. Every star has some planets around it, right? Earth is a planet which is around sun. So stars have planet, right? This is how they form a system, like our solar system, right? Alpha Centauri A, Alpha Centauri B. They are binary pair. Two stars which revolve together is what we call it as a binary pair. Is Alpha Centauri A and Alpha Centauri B. A binary pair. Proxima means near. Proxima Centauri. So the stars which are near to us are Alpha Centauri A and Alpha Centauri A, Alpha Centauri B, Proxima Centauri. What does a galaxy contain? It consists of nebula. Nebula is nothing but the dust plus hydrogen, helium are gases, right? Hydrogen, helium, ionized gas, right? So dust, gas. Now we have dark matter, dark energy. Now what is dark? Let's go for the dark matter. A person is there, but he is not visible to our eyes, not visible to our eyes, right? Now, but if this person beats us, we feel the pain, right? And we can touch this person also. If he is standing, we can touch this person also, right? If something dashes on this person, he might get injured, right? This is what we call it as a dark matter. We cannot see it, but it is present. So this is what we say it as a dark matter. We are unable to see it. Why we are unable to see it is another question. Because a person is there. If he is in a dark room, we cannot see him because absence of light, right? He is not reflecting light. Leave about light, because the entire universe is mostly dark, right? So light, he is not responding to light. At the same time, he is not responding to the electromagnetic waves which we use to detect objects. So he is not reacting to light. At the same time, he is not reacting to electromagnetic waves. That is why we call it as dark matter. Something is present, but it is not visible to our eyes. That is why we call it as a dark matter. We have stars. Nebula becomes stars, right? So you can have this order as nebula, stars, dark matter. We can also have dark energy. Later parts we are discussing about dark energy. So as far as now it is like nebula, star. dark matter, dark energy, and then we have a black hole which is at the center, at their center, right? There is a black hole at their center. So this is what a galaxy consists of. It consists of, first thing is nebula. From the nebula we will be having the stars. Now here we have something which is not visible: dark matter, dark energy, and a supermassive, a very big black hole at the center, right? This is what a galaxy consists of. Universe. Now this is universe, and we have many millions of galaxies inside universe, and inside galaxy we have millions of stars. We have nebula, stars, dark matter, and a black hole, right? Now what does this galaxy universe consist of? We should not write the universe consists of galaxy, dust, gas, nebula, dark matter, stars, supermassive, black holes. We should not write like this. Instead, what we should write? What does universe consist of? Universe is going to have a space, right? In this space only we will be having galaxies, and the space is expanding. That is why we are having the component of space as a element of universe. So space, then we have matter. We are not having dark matter, white matter, light matter, just matter, just energy, and then times. So the keyword for this is METS. Met, right? Matter, energy, time, space. It does not exist before the birth of the universe. Nothing exists before the birth of the universe. Do you think like matter existed before the birth of the universe? No. And space, even the time, energy, nothing existed. So we have met is the keyword, right? Matter, energy, time, space is what the universe consists of. You should not go and write that universe consists of millions of galaxies. You should write very professionally as universe contains the matter, energy, time, and then space. These things does not exist before the birth of the universe. What is an exoplanet? When we have a star, some planets are revolving around this star, right? So a solar system, a similar solar system is being found. Exoplanet is nothing but a planet which is orbiting around other stars outside our solar system. Each star have at least one planet which is revolving around us. So they are difficult to detect in telescopes because this star is very big and it reflects light all over, right? And it is very difficult to determine. They are very close to the stars. Brightness of the stars makes it difficult to determine. Now there are techniques to determine the exoplanet. We have learned what an exoplanet is. Right. Now what are the techniques to determine the exoplanet are transit method, and then we have Doppler spectroscopy method of detection. Right. We have two methods. Right. The first one is going to be the transit method. Transit method is, now we have a star. The planet is revolving around the star, right? This planet must revolve. So initially this is in the position A. It moves to position B, C, D with respect to its rotation and revolution time period, right? The Mercury takes 88 days to revolve around the sun, whereas Earth takes 365 days, right? So this planet is revolving around the star. This is the star and this is the planet. Now let us consider the rays received from here to the earth. It is 100%. Now when this star comes over here, it is slightly touching here. The rays is 99%. But when it is here, the rays are 96%. So this part alone, the rays will have a different direction, right? Now when it is over here, the rays, straight rays, but here alone we have different kinds of rays. So when we detect this, we could find that there is a small planet which is revolving around the star. This method is what we call it as a transit method. To evaluate the size of the planet, whenever a planet passes in front of the star, it is called as transit. So transit means whenever you are passing in front of me, you are being called as transit. So whenever a planet passes in front of a star, it is called as transit. With respect to the position of the earth, right, a small amount of starlight is abstracted, the reduction in the brightness. So a small amount of light alone is abstracted, therefore with reduction in the brightness, we are using this method to determine the location, the size of the planet, right? So this method for determining the exoplanet is transit method. Transit means whenever a star is in front of the whenever the planet is in front of the star, the planet is in front of the star with respect to the position of the earth. The planet is in front of the star, right? When the planet passes in front of the star, it is called transit with respect to the position of the earth. A small amount of light is abstracted. Reduction in the brightness is what we call it as the transit method. Now, exoplanet, we have seen that certain stars apart from our sun have planets revolving around them. So how to find these planets? We have methods like transit method, and then we have the Doppler spectroscopy method. Wobble method of detection. Indirect method is going to be use of periodic shift in the radial velocity. Now, wobble method, apart from wobble method of detection, the first we will look into the indirect method is the use of, we have to Doppler spectroscopy. Spectroscopy is related to the waves, the spectrum of the waves, right? The bandwidth, everything is going to come. So a transit is related to the location, and Doppler spectroscopy is related to the radial velocity spectroscopy. Now when a planet is located at this earth, when a star is located at this position versus a star is located farther from the earth, now light is going to have spectrum red with a wavelength, and then we have blue. The wavelength of the light is going to varies, right? Now when the star is near to us, we have blue light, and if the star is far away from that, we receive red light. This is how we analyze a spectroscopy. Long wavelength is for red, and blue is having a shorter wavelength. See, blue is this, and then blue, red, short wavelength. This short waves reach the earth, but long wavelength reaches long distance, right? So when the stars are near to us, we receive blue light, and when the star is far away from us, we receive red. This is what we call it as the use of the periodic shift in the radial velocity. The use of periodic shift in the radial velocity. The first method we saw is the transit method, and the second method is what we call it as the use of the indirect method, is where the use of the periodic shift in the radial velocity. Now we also have wobble method. Now, what is wobble method? This is used for stars, right? The Doppler shift to detect any tiny wobbling motion. Wobbling motion means you see that the planet rotates around a star, revolves around a star. So there is a shift. First the waves come from one direction and then the waves come from another direction. So wobbling method of detection is also used. This is Doppler, and then we have the transit method. The closest star is Proxima Centauri b. The star is Proxima Centauri. The star is Proxima Centauri, but the closest exoplanet is Proxima Centauri b. Least massive exoplanet is Drog. It is Moon divided by 8. The hottest exoplanet is Kepler 70b, and the biggest is Kepler 39b. Exoplanet is extrasolar planet. Now we come to the concept of dark matter, right? What is dark matter? Gravitational effects on many components of the universe, holding elements by the universe, bind element together is what we have dark matter. It is an invisible. Here we see dark matter. It is an invisible. It does not absorb, reflect or emit light. It does not interact with the electromagnetic force, and it is a hard to spot. A matter which is hard to spot is what we call it as a dark matter. Now what is dark energy? Is nothing but a force. Again, this force is also not reacting with light or electromagnetic energy, right? Gravitational is a force. Likewise, dark energy is a force. After the Big Bang theory, the universe is expanding at an increasing rate. The force behind the expansion of the universe is what we call it as a dark energy. So dark energy is nothing but the force behind the expansion of the universe is what we have the dark energy. We have dark energy is nothing but the force behind the expansion. Now we are facing the expansion, right? Expansion of universe is what we call it as the dark energy. Is nothing but the force behind the expansion of the universe is what we have dark energy. Now dark matter is an invisible matter which does not absorb, reflect or emit light. It does not absorb, reflect, as well as we say it as emit light. It does not interact with the electromagnetic force, and it is hard to spot. International research. Primordial black holes is formed at the early age of the universe, might be the primary source of the dark matter. This concept is proposed by Stephen Hawking. The dark matter makes up about 95% of the universe. These both things, dark matter and dark energy. It prevents the stars in the Milky Way galaxy from flying apart. The stars in the Milky Way galaxy, they stay compact, right? It is because of the black hole which prevents the star from flying apart. Now we have Mercury takes 88 days to revolve around the sun. Now here the gravitational force is strong with respect to Mercury, but the gravitational force is weak with respect to Neptune, as it takes 165 years, and the distance between Sun and Mercury is huge. Therefore the gravitational force is weaker. Gravitational force at the center of the galaxy, there is a black hole, right? So this is responsible for holding the stars at the center and the stars at the edge same time for one revolution. So invisible and envelope force is giving an extra push to the outer star to speeding up them. This is a comparison example, guys. First we have Earth, right? Sun. Sun is using its gravitational pull, and with this strong gravitational pull, the Mercury is revolving faster. But due to weak gravitational pull, the Neptune is revolving slower. But here we have a galaxy, the center of the galaxy, we have a black hole which provides sufficient gravitational pull. The star at the center must rotate faster, right? The star at the edge must rotate little slower, right? But both the stars are having, a star at the center and a star at the edge are having same time for one revolution. So some invisible and enveloping force gives extra push to the edge. Star is receiving some extra push to speed them up. Now dark matter is having gravitational attraction. Right, matter means it is showing some gravitational attraction. Energy is a force. So here dark in the sense it does not react with the light or any other electromagnetic spectrum. A black hole is a region of the space where the gravitational field is extremely intense. No matter or radiation can escape. Once you enter into it, you cannot escape. Right. So what is a black hole? Is a region of space. In space we have a region, and this region is what we call it as a black hole. This region is having gravitational force. A gravitational field is very intense. So we say that no matter or we say radiation is nothing but the energy escapes. No matter or energy escapes in a black hole. Is a region of the space where the gravitational field is very intense and no matter or radiation can escape. Now what is primordial black hole? Is very ancient black hole. That is the black hole which is formed at the time of the Big Bang. Initial instant of the Big Bang, the densities would have been very high at many points, resulting in the formation of high density. Density is very high at the black hole, right? Now what is gravitational lensing? Albert Einstein's theory of relativity. Gravitational lensing is a topic which was very famous recently, right? And gravitational lensing and theory of Einstein's theory of relativity, right? Now this gravitational lensing, we have a black hole, right? We have a star, black hole. The black hole is having high intensity of gravitational field, right? So it attracts the rays, right? Now the rays bend, certain rays escape, certain rays fall into the black hole, whereas certain rays bend, and a viewer can receive light from the star, but he couldn't locate the star itself. He just could see some light which is around a black hole. A light around a black hole alone can escape, right? So it is circular. There is a lensing effect, right, which is able to spot the black hole. Therefore we call this as gravitational lensing. Lensed galaxies images. Right. Now the concepts of gravitational lensing and Albert Einstein's theory of relativity. Right. Now first we saw what is gravitational lensing. The star becomes brighter because bright light is coming over here. The rays are bent inwards like a lens. Theory of relativity. The speed of the light within a vacuum is the same, no matter the speed at which the observer travels. This is what we say theory of relativity. Now we have solar system. In solar system we have sun, right? The sun and 8 planets. The planets are due to condensation of gases. The surface temperature and then the interior temperature. Surface temperature is 6000 degrees Celsius, whereas the interior temperature is 20 million degrees Celsius. So the surface temperature of the sun, and then we have the interior temperature of the sun. The surface temperature of the sun is 6000 degrees Celsius and the interior is 20 million degrees Celsius is the interior. So sun is having a surface temperature of 6000, whereas interior is 20 million degrees Celsius. Elliptical orbit. The orbit is being elliptical. Shine planets reflect the light of the sun. The shine in the planets is because they reflect the light of the sun. Sun planets are having satellites, asteroids, meteorites, comets. We have to discuss all of them. Sun. So how to remember planets? We all know planets, but this is again a mnemonic. My very educated mother just showed us nature. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. My very educated mother just showed us nature. So what happened? Why Pluto is out of planet list and it has got a status of a dwarf planet or a Kuiper object? This is Kuiper spelling. Now we have the sun, right? There are certain conditions for a planet. It should have an independent orbit. But the orbit of the Pluto has crossed the orbit of the Neptune. In 1979, it went into the orbit of the Neptune, within the orbit of the Neptune. So we have this as Neptune. So after Neptune we have Pluto. So what should be the revolutional orbit of Pluto? This should be like this, something like this, right? But it went into the orbit of the Neptune in 1979. It went inside and it came out in 1999. Therefore it has high eccentrical and International Astronomical Unit. The summit removed it from the status of planet and it gave the status of a dwarf planet or Kuiper object. Planet should have three conditions. The shape is spherical, revolve around the sun, and the orbit should not be eccentric. It must be elliptical. Elliptical orbit, right? It should not be eccentrical orbit. So these are the rules, right? It should not be eccentric. It should be elliptical. Now the conditions for the planet is it must be spherical in shape, it must revolve around the sun, and it should be elliptical. It should not be eccentrical, right? Neptune came out and it came out of the Neptune in 1999. Then the structure of the sun, right? First we have the core. RC, right? RCB, RC, radiate. Convection. Radiation is where in radiates light. This is what radiation. Whereas convection is the movement of the particles in a liquid. Radiation is the movement which is similar to in the gaseous. Radiation, convection, and then we have photosphere. Radiation, convection, then we have photochromo, corona. This is the corona. After corona we have like some sunspots, some black spots, like the sunspots are located in the photosphere. Then sunspot, granulation. Here we have granulation. Prominence. Some magnetic field which is coming out, which what we call it as a prominence. High intense magnetic field, right? Hotter and less dense material is going to rise and the colder materials is going to sink, and this is how the transfer of the heat. First, core, it is very highly reactive, therefore it is going to radiate its energy, right? So this radiation is going to happen, radiative zone. Convection is the magma, movement of the magma. So like this. So magmatic movement is going to be, the lava movement is going to take place at a zone, and in a liquid state. So this is what we call it as convection. After the convection, the first layer is photosphere. We will be having the sunspots. The second layer is chromosphere, final layer, right? And after that we have corona, is a light, right? Corona. And after corona we have sunspots, granulation, prominence. Sun, the size of the sun is 3 lakh times that of the earth. The distance between the sun and earth is, whereas the distance between the sun and the Mercury is 36 million miles away, and it is 88 days because of the hottest because it is very near, and due to the solar winds, Mercury is devoid of atmosphere and the gases escape. Therefore it is not the hottest planet. The hottest planet is the Venus because it has an atmosphere. Mercury does not have an atmosphere, therefore it is not a hottest planet. Mercury is devoid of the atmosphere, therefore it is not a hottest planet. The hottest planet is Venus. Gaseous atmospheric composition. It has 90%, Venus is 90% of carbon dioxide, which is a greenhouse gas. Therefore it is hot because the greenhouse gases are at atmosphere. We have in the earth more than 70% of 72% of nitrogen, right? 27% of oxygen, and the remaining 1% are other gases, in which the greenhouse gases hold very less percentage. But whereas 90% of the Venus is carbon dioxide, which is a greenhouse gas. So 90% of the Venus is carbon dioxide and it is a greenhouse gas. The terrestrial planets, Mercury, Venus, Earth, Mars alone, Mars, and then we have the Jupiter. There is a belt of rocky fragments which is called as the asteroid belt. It is a fragment of planets, therefore we call it as planetoids. So between the Mars and then we have the Jupiter, we have the asteroid belt. Between the Mars and the Jupiter, they are asteroid belt. They are the fragments of the planets and we call them as a planetoids. They are inferior planet. The orbit is inferior to the Earth. Mercury and the Venus are inferior planets. Their orbit is inferior to the Earth. The size of the planet increases. Exception is Mars. Mars is a red planet. As we move from Mercury, Venus will be bigger in size, and Earth is similar size to Venus, but Mercury is smaller in size. This alone is an exception. And Jupiter is bigger, Saturn is even bigger, Uranus is bigger than this, Neptune bigger than the Uranus. As we move, the size of the planet increases. Exception is Mars. Mars is a red planet. Venus is the hottest planet and a gaseous atmosphere, which is consisting of 90%, a gaseous atmosphere which consists of 90% of carbon dioxide. So it is a gaseous atmosphere which consists of 90% of carbon dioxide and greenhouse gases, right? Mercury, Venus, Earth, Mars, Jupiter, we have the asteroid belt. Fragments of the planet or planetoids: Saturn, Uranus, Neptune. The largest asteroid is Ceres. Jovian planets: Jupiter, Saturn, Uranus, Neptune. Just show us nature. They are Jovian planet. My very Mercury, Venus, my very what, mom? Just forgot the mnemonic. Educated mother. Education. So my very educated mother just showed us nature, right? Mercury, Venus, Earth, Mars are terrestrial planets. The remaining planets are called as Jovian planets. Between the Mars and then we have the Jupiter, we have asteroid belt, right? In the asteroid belt, the biggest asteroid is what we call it as Ceres. Ceres is the biggest asteroid, is what we call it as a Ceres. Now, between Sun and the Earth, we have 1 astronomical unit. Between Earth and Neptune, we have 30 astronomical unit. Between Neptune and the heliopass is where the sun rays stops, right? Heliopass, we have 70 astronomical unit. So 1 astronomical unit is 150 million kilometer. Between Sun and the last planet, that is the Neptune, we have 30 astronomical unit, right? We have 30 astronomical unit. Between the Neptune and then heliopass, we have 70 astronomical unit. So total between the Sun and the heliopass, we have 100 astronomical unit. Jupiter, Saturn, Uranus, Neptune are Jovian planets, gaseous planets, the planets of the outer circle, right? Big boss is Jupiter, Jovian planet. Venus is the oddest twin. The Earth revolves eastwards around the Earth once in every 27 the moon revolves eastward around Earth once in every 27 days. So the revolution time period of the moon is 27 days and it rotates eastwards. So we have east. So this is how the rotation of the moon towards around eastward. Mars, dark patches on its surface, is believed by most professional astronomers to be the next planet after the Earth to have possibility of life on Mars. All the planets' rotation is from west to east, right? Where exception is going to be UV is the exception. Uranus and Venus is the exception. The sun rises in the west. They rotate this direction, east to west. The exception is UV. Uranus and Venus are the exception. Eastern part facing the sun faster and the sun rises in the east. West to east is where the sun rises in the east. West to east and then the sun rises in the west for UV. So the sun rises in the west for UV. The planets with a system of rings is Jupiter, Uranus and then Saturn is having rings. So the last planet Neptune is also having a system of rings which are not visible to us. So Jupiter, Uranus, Saturn, Neptune, they have rings. Jupiter, hydrogen, helium plus methane. It is distinguished from the planets by its circular light and dark bands. The maximum satellites is Saturn has Jupiter has the maximum satellites. Jupiter is having hydrogen, helium plus methane, right? It is distinguished from the other planets by its circular light and dark bands. Now is this Jupiter? We have to divide. Light band, dark band, light band, dark band. So a circular bands is present over the Jupiter, right? It has a maximum number of satellites is Jovian planet Jupiter. Clockwise direction from east to west. We have other planets have what is called as anti-clockwise. So Uranus is having the clockwise direction from east to west. Neptune closely resembles Uranus. Sun, Earth. This is aphelion and perihelion. Aphelion is the sun. Away. So aphelion means the sun is away from us. Perihelion is the sun is near us. Aphelion and perihelion is the location of the sun and the earth, right? When it is close to the earth is 147 million kilometer and away is 153 million kilometers. In January, it is a summer month for southern hemisphere. That is why we have Australian bushfires. January is summer for southern hemisphere, and the only few places which we have in the southern hemisphere is Australia, right? One of the few places at the southern hemisphere is Australia. Australia faces bushfire. January is summer for summer, extreme hot summer, whereas June it is far away, right? So leap year, if it is a leap year, it is July. We have winter in the southern hemisphere. It is far, we are dealing with the southern hemisphere. Summer, winter are opposites, right? So January, and then 6 months after January, that is June. So January, and then we have the June, right? So 6 months after the January is what we have the June. January is the southern hemisphere. Summer for the southern hemisphere is January. So January is summer for the southern hemisphere. Australian bushfire. June last year, leap year, winter, and then it is a leap year. Winter for the southern hemisphere. One astronomical unit is 150 million kilometer, the distance between Earth and the Sun. The shape of the Earth, we saw that the circumnavigation and circular horizon. These are just, we have some factual details over here. Previously we had only diagrams. Ship's visibility, sunrise and sunset, lunar eclipse, solar eclipse is sun, moon, and then earth. Planetary bodies are spherical, driving poles on the level ground on a curved earth is Bedford level experiment. Aerial photographs. Earth's movements, we have rotation, revolution, right? First we have rotation. Rotation is west to east in the anti-clockwise direction. This is very important because of the rotation we have day and night. Because of the revolution we have seasons and a year, right? Because it is rotation alone is responsible for day and night. Revolution is responsible for seasons and a year. So we have rotation and revolution. Rotation is from west to east in the anti-clockwise direction, day and night. Revolution is around the sun in an orbit it's round the sun in an orbit, elliptical orbit. 365 1/4 days. So we have it as 365 1/4 days is the revolution period of the earth. It is responsible for seasons and years. Elliptical orbit. The rotational speed is going to be per second or per hour. We have to remember this. The speed of rotation of the earth per second is 18.5, 66,600 miles per hour. This is miles per second. This is miles per hour. We are looking at the speed of the orbit, the speed of the revolution, not rotation. The rotational speed is 24 hours. The revolution speed is 18.5 miles per second or miles per hour. We have 66,600, 66,600 miles per hour. Varying length of day and night. Why we have varying length of day and night? In some areas, the length of the day is just 10 hours, whereas the night is 14 hours, right? It is not 12 hours day and 12 hours night. This is because this is the axis and the earth is tilted. So for reference, I am drawing, this is the tilt of the earth, right? Because this is the original north pole. This is geographical North Pole. This is the original flat North Pole, 90 degree. It is tilted and the tilt is 23 and a half. This is the tilt. Alright. From the equator, when we take it, it is 66 and a half. 66 plus 22 and a half, 23 and a half is what we have, 90 degrees, right? From the equator, it is 66 and a half inclination, plane of, this is a plane, right? Plane of elliptic. Varying length of day and night is because of the axial tilt of the earth is 23 and a half degree, or we can also say it as 66. Plane of the elliptical. Tropic of Cancer, Capricorn. Arctic Circle 66 and a half, Antarctic Circle 66 and a half. Right. Then we have North Pole and South Pole. So Earth. Tropic of Cancer 23 and a half, Capricorn 23 and a half south. Arctic Circle is 66 and a half north, Antarctic Circle. Northern Hemisphere, the winter is in the December. In the Southern Hemisphere, the summer is in the January. Northern Hemisphere, winter we have darkness is high. Arctic Circle, winter is complete darkness for the whole day, is 22nd December. So 22nd December is having Arctic is having a complete night for 24 hours, and 21st June is where the day for 24 hours. Summer is called as a land of midnight sun. Midnight also we are having sun, right? So December 1, January, February, March, April, May. So almost it's a 6 months calculation. December to January is 1 month, right? Because it is starting from the December 22nd and June 21st. So we are looking into a detail where there is complete darkness in the northern hemisphere. Northern hemisphere during the December, it is, we see Christmas and we see snowfall, right? So it is winter. So this is how we remember in northern hemisphere, December we see snowfall during the Christmas, right? And then they make snowman, right? They make snowman also. So this is the clue. We have to remember that northern hemisphere, most of the population lives in the northern hemisphere. So it is winter for them during December, right? So in above the Arctic Circle, that is 66 and a half degree, we have complete darkness. Entire above 66 and a half degree, this entire space is darkness. It is in 22nd December, and 21st June we have complete brightness, and this complete brightness is called as a full day sun. Land of midnight also it is having sun. -6.5 north. North Pole is having complete daylight for 6 months. For 1 full day only we are having complete light in the Arctic Circle, which is 66.5. If you go for 90 degree north in the North Pole, right, 6 months from December to June, it is complete sunlight, right? So we say that the Arctic is northern hemisphere. December it is winter for them, right? So winter is complete darkness in 66 December. Here it is dark, right? Then we have complete summer for complete brightness in 21st December. Land, midnight, sun. Now this is the diagram for, so in the North Pole is having sunlight from June to December. December is when the winter is starting, right? In June there is sunlight. 21st of June, sunlight enters in the Arctic Circle. So from June till December 22nd, it is going to be summer, right? December 22nd is when the winter enters into the Arctic Circle, and it is complete darkness in 22nd December. Therefore, from June till December 22nd, June 21st to December 22nd, we have complete light in the northern hemisphere. Now, June is light for the northern hemisphere, so June is dark for southern hemisphere. December is winter, whereas December is summer for the southern hemisphere. Opposite for the northern hemisphere is southern hemisphere. So we start here, right? This is how the sun's rays moves as earth is rotating and revolving around the sun. Revolving is alone brings the with respect to North Pole, we have summer in 21st June, right? Winter in December 22nd, right? Now between this we have here equinox, equal day and night. 4 points we have equinox, right? Equal day and then we have the night, right? So this equal day and a night, this point at the equator, we have equal day and a night. This is at March 21st and September 23rd. March, April, May, June, July, August, September, leave 2 months. October, November, December. March 21st, June 21st, December 23, September 23 and December 22. So these are equinox. This is summer solstice and winter solstice in the northern hemisphere, right? Midday sun means the sun's rays are vertically overhead. The sun's rate is directly 90 degree is what we call it as a midday sun. Sun's rate are vertically overhead at the equator. Equinox is equal nights. 21st March and 23rd is September is equinox. Day change will happen over here because 365 1 by 4, right? March equinox. March, when there is an equinox, the sun is at the northern hemisphere, right? Moving towards the northern hemisphere, vertically overhead to the Tropic of Cancer at the 21st June, summer solstice. Sun is 90 degree, the sun is vertically overhead over the equinox is when the equator, the sun is overhead in March 21st and September. In 21st June, the sun is overhead in the Tropic of Cancer. In 22nd December, the sun is overhead at the Tropic of Capricorn, right? So we say here the sun is overhead at the Tropic of Capricorn. So the Tropic of Capricorn is going to have equal day and equal nights at 22nd December. Now we have at the Tropic of Cancer, here we have equinox, right? Equal day and night. Equal day and night is not equinox when it is at the equator, and equal day and a night. So here we have, now we are in 22nd December. Now here, if it is complete light, here it is going to be a 24 hours light, right? The sun is here, so this area will have darkness, so 24 hours night. Therefore December is winter equinox winter solstice for the North Pole, whereas it is summer solstice for the South Pole, right? Let us have a detailed discussion of this. Here we have some space. Equator. First, the sun rays are vertically overhead at the equator. It is happening at two dates. Okay, here also another sun. Let us imagine. First, the date is 21st March. April, May, June. June, the sun is going upwards. June 21st. 23 and a half. This is. You cannot write over here. Wait. This is the equator. Sun is vertically above the equator in 21st March. This is Tropic of Cancer, Capricorn. 23 and a half north, 23 and a half south, 66 and a half north, 66 and a half south, North Pole, South Pole. This is in 21st July. Now the sun goes here. No, the sun doesn't goes here. This is what we have to notice, right? After, what happens is that from here it goes here, right? Then the sun comes down. Again, when it is coming to the equator, it is 23rd July, right? August, September. Sorry, this is June. August, September, October, November, December. That's it. Again, January, February. You have to leave 2 months. January, February. Leave January, February. It is going in March. April, May. You have to leave June. July, August, September. The sun just goes in a cycle between Tropic of Cancer and Tropic of Capricorn alone. October, November, December. Right. Wherever the sun is present. At that place we have 24 hours is equally divided between day and night. So 24 hours we have 12 hours of day and 12 hours of night. Now let us decode this. Okay, first in 21st March, the sun is straight in the equator, right? Equator has 24 hours day, 12 hours day and 12 hours night. Again, one small reference diagram. Okay, now the sun is at the equator. How does the rays goes in a slanted way to the other areas, right? So days are shorter, nights longer, right, in remaining areas. So the difference here, you see, here it will be like 10 hours of day, 14 hours of night. So it is not actually just 2 hours of difference between day and then night, right? It is not winter. Between summer and winter we have spring and then we have autumn. Spring, after spring we have summer, and After autumn we have winter, right? So it is spring, then we have summer, then we have autumn, then we have winter. Okay, now the sun is going to, first it is in equator, next the sun goes to the tropic of Cancer, right? When the sun is in the straight line, it is summer. So from here, from equator, it is traveling up, right? So here summer, next is summer. So at the, in 21st March we are speaking here, at the tropic of Cancer, it is spring, right? Now in the tropic of Capricorn we have autumn. That's all. Okay, so this is what we have in 21st March. Okay, now we see the sun is moving here. March, you have to leave April, you have to leave May, the sun is just traveling, April, May. In June it is reaching, 2 months for traveling. Okay, so in June it is reaching. Now let us consider what happens in June. June 21st, Earth equator, 24 hours is divided, right? Now here is tropic of Cancer, the sun is here, right? So when the sun is near, rays receive over here, straight rays, right? So slanting rays receives over here. So here we have 24 hours summer for 6 months, entire 6 months. But in 21st June we have tropic of, apart from tropic of Cancer, we have Arctic Circle. Arctic Circle. So first we will go stepwise. First, what happens in the tropic of Cancer? It is equal day and night, but sun is very close to Arctic Circle, right? In Arctic Circle we have 24 hours daylight. This is what we call it as a midnight. Also we have the sun. So what do we say in the Arctic Circle? It is summer started, right? So summer has started. Summer lasts for 6 months. Summer, then 3 months we have autumn, then we have winter. So the duration of the summer to winter is 6 months, right? Now during this 6 months, from June to December, we have summer in northern hemisphere. When December 22nd reaches, we have Christmas is snow, right? So we have 24 hours of night at Arctic Circle, 66.5 degree north, right? Snowfall is there, so it is winter. Now here in the North Pole, from December till June, it is night. North Pole has 6 months day, 6 months night. Simple rule for North Pole. In Arctic Circle, Antarctic Circle, we have sunlight, day and night variations. Day may be 24 hours, night is 0 hours, 23 hours, 1 hour. This is the variation which is happening in per day. Variations are happening in Arctic Circle, but month variations are in the North Pole. 6 months continuously light and 6 months continuously darkness. So from June till December, it is continuous day in the North Pole. Okay, now 21st March, the sun is in the Tropic of Cancer. So we have 21st June is 24 hours of day in the Arctic Circle. Right. Now, after June, July, August, winter, September. Now, 23rd September, again there is equinox. Sun is moving between Tropic of Cancer and Tropic of Capricorn alone. Now we are dealing with 23rd December. 23rd December, we have sun again coming to this point, right? Next, the sun will move towards the Tropic of Capricorn. Tropic of Capricorn. Tropic of Cancer. Now the sun is here. So Tropic of Cancer will have autumn, because next the sun goes down, right? This is not 23rd December. September, sorry. 23rd September. June, July, August, September, right? September it came back over here. So in equator we have equinox. Then in the Tropic of Cancer we have autumn. Tropic of Capricorn we have spring. Then this is spring, but even colder, right? So here it is a cold season. Now let us go for 22nd December. The sun is in the Tropic of Capricorn, right? So our Antarctic Circle has 24 hours of day. So Arctic Circle has 24 hours of night, and North Pole will have December to June darkness, right? South Pole will have December to June day or brightness, continuous sunlight. This is how the seasons variation of the seasons, right? Summer solstice. When is the summer in the northern hemisphere? It is the longest day and then shortest night is what we have the solstice. So summer solstice in June 21st is the summer solstice for the northern hemisphere. December 22, the sun is overhead in the Tropic of Capricorn. So winter solstice is for the northern hemisphere. December 22, longest night and shortest day. Solstice is the longest night and shortest day. Tropics marks the limit of the overhead sun. For beyond these, the sun never goes overhead at any time of the year. So we say that the tropics, they mark the limit of overhead sun. Beyond the tropics, the sun is never overhead at any time of the year. Vertically overhead is what we call it as a midday sun. Vertically overhead means 90 degrees sun, earth, vertically overhead. Heat concentration in a small area. So when the sun rays fall vertically overhead, the heat is in this area. When the sun is earth, right, straight, it is less area. Slanting covers more area, but less heat. Less area, more heat, more area, less heat. Summer is the overhead sun. The rays fall vertically on the earth. Longer day duration. Temperature rises. Summers are warm. Winter sun rays are oblique or large area. They cover large area. So sun rays are vertical and oblique is the opposite. Come through the atmosphere less directly and have much of the heat absorbed by the atmospheric impurities and water vapor. Dawn is sunrise. Okay. To full day light is what we call it as a dawn. Twilight is when the sun is setting. To complete darkness, the sun is rising. To full day light is what we call it as a dawn. Twilight is when the sun is setting. It starts to set, whereas we have complete darkness is what twilight. Diffused or refracted light from the sun is when, this is the time when we receive diffused or refracted light from the sun. Sun rises till complete light is what we call it as a dawn. The sun is going to set to complete darkness is what we call it as twilight. We also have a movie called Twilight, a vampire movie. So once the sun sets to complete darkness is when the vampires come, right? So sun is vertical part at the equator, is refracted light is short, refracted light, so this is vertically at the equator. Less slanting means it covers more area but less heat. In temperate latitude, in the earth it is vertical.